Dear student, once again, all of you are welcome to my YouTube channel, Math Success Point. I am going to start actually the very important topic, that is continuity and discontinuity of the function, which is the very important part of your differential calculus. And let us see the continuity of the function. That is why I will take to explain the continuity by taking different examples, so that you will understand easily. But before starting this topic, continuity, I will request to all of you, like my channel, like my video and subscribe my channel, so that I shall be benefited. Not only benefited, I shall be motivated, so that I can motivate you after giving the solution of different types of questions. Okay, let me start the continuity of the function at different types of points. Okay, let me take the graph, and so that easily you will understand by using the graph, that is axis, y-axis, and that will be x-axis. My dear student, I am going to take the graph of the function, that is y is equal to fx. Try to understand, which is a very important. And I am going to take a point on this graph, A. All of you know this will be equal to, if y is equal to fx, in place of x you will take A, because that is the value of x. On x-axis, at A point we will discuss whether the function is continuous. Continuous means continuity. The function will be continuous. There will not be any breakage of the graph. Like you have drawn the different types of graph continuously without any break. That is why try to understand it. It will be in place of x, right? A. That is why its value will be A. From this point, suppose this is B point, up to here. Up to here it will be fa. And the function will be continuous. Fx is continuous. My dear student, you try to understand this definition so that you can understand the solution of the question. Fx is continuous at x is equal to A point. A point already I have taken. At A point of its domain. Domain is all the points on x-axis. You can discuss, you can take. Not only A, in place of A you can take 1, 2, 3, 4, 5, like anything. But thing is that one concept, limits and differentiation, you have studied in class 11. Limit. If limit exists, then only the function will be continuous, otherwise no. How you can say that the limit of the function at a particular point will exist? If left hand limit is equal to right hand limit, then the limit will exist at that particular point, which you are going to take. I am taking here the point A. At point A, the left hand limit of the function, left hand limit should be equal to the right hand limit of this point. Left hand point, suppose here it is 2. Left hand point will be what? 1.1, 1.2 and so on up to 1.9. Another point in between 2. Right point will be 2.1, 2.01, 2.001, 2.18, like anything. So many points will be there. These will be the right points of 2. That is why in the standard form we are going to take point A. And what will happen? I am just going to write the condition first of all. The function will be, first case, you must keep in mind, the function will be continuous. Fx will be continuous if it is equal to A. I told you many times, I discussed many times, x tends to A. It is not equal to A. There may be a little less value of A, a little greater value of A. Less value of A means left limit. Greater value of A means right limit. That is why you see carefully. Okay? And second case, I am just going to write over here left limit of this function. I am going to write a in the left one as well as in the right one. It will be equal to what? Right limit of a fx, and that should be equal to fa. Then only the function will be continuous, otherwise the function will not be continuous. What does it mean? Suppose you start from here and approach towards a from the left side, approach from the right side towards a. That will be the left limit, that will be the right limit. Similarly here, approach towards P point from the left, approach from the right side towards P at this point. Means this is point A, this is point A. Left limit should be equal to right limit and should be equal to fa. Fa means this value. Then the function will be continuous. If there is a breakage of it here, then the function will not be continuous. And this definition you must have to keep in mind. If the left limit as well as the right limits are equal and it should be equal to fa, then the function will be continuous. Otherwise, the function will not be continuous. There may be one more thing I will discuss later on. First of all, I will discuss some questions. Removable discontinuity. Removable discontinuity means which can be removed. If the function is discontinuous, that can be removed, and that can be changed into the form. Into what form? The function will be continuous after changing the value of fa. After changing the value of fa. That is why you see, I am just going to take the question whether you will have to see whether the function will be continuous or not. Let me take. But you must have to keep in mind this formula of continuity. Okay, then I am going to take the question related with the continuity and discontinuity, whether the function will be continuous or not. And I will take first of all the easy question so that you will understand. Examine the continuity. Examine the continuity of the function. Examine the continuity of the function. What function? Function I am going to write over here. fx, that will be equal to, my dear student, you must have to concentrate properly. 3x minus 2 if x is less than or equal to 0, and x plus 1 if x is greater than 0. At what point you will have to discuss the continuity or discontinuity? X is equal to 0. Examine the continuity of this function at x is equal to 0. Okay, let me take the function. First case is this one, means x is less than 0. X is less than 0 means left limit we will take using limit x tends to means left limit of fx. What is its meaning is less than 0. Less than 0 means x is less than 0. Function is 3x minus 2. Take it, tends to 0, and in place of fx, then it will be equal to 3x minus 2. Okay, but in future I will use the procedure as I have used, whether the function is differentiable or not. Similar kind of method I am going to use. Actually, its value will be equal to, if you will substitute the limit in place of x 0, it will be minus 2. Okay, but I am going to put the procedure properly. X is equal to, because I told you x it is not equal to 0. X tends to 0 means it is not equal to 0. There may be less value or may be greater value. That may be 0 minus h. If x tends to 0, then h tends to 0. Okay, let me take limit h tends to 0. 3 in place of x you write, because same value you will get. Take the limit h tends to 0, 3 minus 3h or minus 2, that is 2. It is not x, it is 2. Minus 2. Take the limit, in place of h you will put 0, it will be minus 2. That is why left hand limit is minus 2. Similarly, that you can take left hand limit, it will be equal to this one. I am going to take the right hand limit, second case. Okay, then it will be equal to limit x tends to 0, right hand limit I am going to take limit x tends to 0 and the function is x plus 1. When it is greater than 0, you see. It will be equal to how much? Similar kind of thing you can put x is equal to 0 plus h. If x tends to 0, h tends to 0. Similar kind of thing you will have to put h tends to 0 and in place of x you will write 0 plus h and plus 1. Okay, directly you take the limit, this value will be 1. My dear student, you see whether the left hand limit is equal to the right hand limit. These are not equal. If these are not equal, then what will happen? I am just going to draw the graph. The function is, because you see therefore limit left hand limit does not equal to right hand limit. Then, so function is what? F is not continuous. Fx is not continuous. It is not continuous. Numerically I told you it is not continuous. The function is not continuous. Let me take what is the graph of it, whether the function is why it is not continuous, why it is discontinuous. What will be the reason of behind it? You see carefully the graph of it. I am going to take a very small graph. I am just going to draw, try to understand. X-axis and y-axis. Origin. Okay, I will take here 1, minus 2. My dear student, first you see, whenever see the graph, x is greater than 0, this is the function. You see, function. If fx will be equal to x plus 1, if x is greater than 0. Okay, greater than 0 means if x will be 0, then you will start from where? 1. You will start the graph 1. This will be the graph, straight line, you can draw the graph of it. Fx will be equal to x plus 1. This is the graph. See carefully this thing. What is that? See once again, x is greater than 0, but equal symbol it is not even. That is why x is equal to 0 will not be included. You see the open interval. X is equal to 0 will not be included, that is greater than 0. Okay, similarly, you see the point, next point, if x is less than 0, then what will be the function? This function. If you will draw the graph, then this point will be included, because you see, x is less than or equal to, less than is 0, graph will be like that. This will be the graph, and equal to 0. That is why this point is included here. Okay? And it will be equal to what function? Fx will be equal to 3x minus 2. This may be the graph of this function. And you see, function is continuous in this direction of fx. If you will take, this is a polynomial, and graph of polynomial always that is continuous. Polynomial function always continuous. This is also polynomial, but from this point, this is continuous. But there is a bracket from minus 2 to 1. Here the function is not continuous. That is why we have calculated the function is not continuous. Function is what? Discontinuous. I told you what is the discontinuity by drawing the graph. That is why, my dear student, try to understand the solution of the question. I have given you the very important solution, and let me take the one more type of question. Then important questions I will try to give you. Okay, let me take another thing which is very important because your examination is very near. That is why I want to tell you the important concepts to you, so that you will be benefited. At least you can solve if suppose the question will depend upon it asked in the examination. At least you can give the solution of the question. Okay. See, dear student, I am taking the removable discontinuity. Removable discontinuity. Although I will take a number of questions related with the continuity and discontinuity, but today, you see, I am going to take the important things only. That is why you see the function fx is discontinuous. Removable discontinuity is said to have removable discontinuity. Removable, which can be removed, discontinuity at x is equal to a. Dear student, you see, I am just going to draw the small graph so that you will understand by the graph. I have discussed the point A. This is x-axis, x dash, y and y dash. Okay, and let me take this graph. And this is what? FA this is. See, I want to write the condition. You see, for continuity, we are approaching towards this point from the left, and we are approaching towards this point from the right. What will happen? You see, left limit at this point of the function, it is equal to limit x tends to a, right limit of the function, but does not equal to f. You see, it is not equal to f. Left hand limit, we are approaching left hand limit is equal to right hand limit at this particular point. But it is left hand limit is equal to right hand limit, but it is not equal to a. This is open. Open means it is not equal to fa. That is why does not equal to fa. If such type of things arise, then it will be removable discontinuity. You can remove. After removing the number or the function, you can make it, the function will be continuous. Let me take the question related to this one. Okay, and you will automatically understand. Removable discontinuity. Let me take the question. See, what may be the question? The function. See the function fx. I am going to write the function fx. That is x square minus 1 upon x minus 1. Okay, and condition is there if x does not equal to 1. And next condition for if x is equal to 1. Okay, my dear student, let me find out the left as well as right limit. At what point? 1. Solution. Limit left hand limit. Okay, x tends to 1. This will be the left hand limit. I told you already, it is not equal to, does not equal to 1 means it is not equal to left limit. Same function you will take. X tends to 1 and function is what? X square minus 1 upon x minus 1. Okay, let me take its value directly as I told you the procedure. What is its factorization? X minus 1 and x plus 1. My dear student, you must know the rule of limits. First of all, you change the function into the simplest form, then you take the limit. Otherwise, you will commit the mistake. Because if directly you will substitute the value of x, 1 square minus 1, 1 is 1 minus 1, 1 minus 1, 0 by 0. That is indeterminate form of the limit. Indeterminate form of the limit. That is the wrong procedure. That is why you see first of all factorize the numerator as well as the denominator and consider the common factors. It will be equal to what? Limit, left limit x plus 1. Dear student, I am taking directly the limit. In place of x you can write 1. That is why 1 plus 1 it is equal to. Similarly, if you want to take the right hand limit, same kind of thing you will get. Limit x tends to 1, right limit of f, same kind of function will be there. X square minus 1 upon x minus 1. Okay, it will be equal to x tends to 1 and x minus 1 and x plus 1 divided by x minus 1. Okay, it will be cancelled and limit x tends to 1 and x plus 1, its value will be 1 plus 1, that is 2. Means left hand limit is equal to right hand limit. But one thing, f1 is equal to, if x is equal to 1, f1 will be equal to 4 in the beginning divide. Then what happened? Limit, left limit of this function. It is equal to what? Right limit of this function. But does not equal to f1. It is not a function, continuous function. It is the discontinuous function. But what kind of discontinuous function? Removable discontinuous function. How you can remove? If in place of 4 you are going to write 2, if x is equal to 1, the function will be equal to 2, then the function will be continuous. Okay, let me take it. Removable function. That is why you must try to see. The function has removable. Here you can write the function fx. Fx has removable. Discontinuity. Removable discontinuity at x is equal to 1. But how you can remove it? As I told you, in place of 4, you can take what value? I am going to write that function here. See, if in place of 4 you are going to write 2, then what will happen? Discontinuity of fx you can remove it. Then therefore discontinuity of fx at x is equal to 1 is removed. That is known as the removable discontinuity of the function. Like that, I have given the very important definition of continuity as well as the solutions of different types of questions. My dear student, I think all of you will understand, and you must have to get the good marks in the forthcoming examination by doing the practice, because practice makes a man perfect. And I request all of you, like my videos and subscribe my channel, all of them, so that I shall be motivated and you will be benefited. Thank you to all of you.